Welcome to my Introduction to Networking course, also known as ITN. This is the version 7 material preparing learners for the Cisco CCNA 200-301. Cisco curriculum, everything is owned and copyrighted by them. Services for functionality. DNS, DHCP are the big two. DNS is Domain Name Service. Again, it translates a fully qualified domain name, FQDN, like www.cisco.com, and it actually allows us to translate google.com to a IP address. That IP address is then forwarded to the client. The client will use the IP address to route accordingly. Again, routing uses IP addresses. Basic networking deals with IP addresses. We, people, need to know names. That's where DNS comes into play. DNS has several different types of records. The most common types of records are like an A record. That is where we have a domain name and we associate it with a IP address. If we're talking IPv4, it's a single A record. If we're talking IPv6, it's a quad A record. If we're talking a authoritative name server, it will be called a NS record. If we're talking a mail or an exchange record, it will be called a MX record. These are different types of records that are used when dealing with DNS. If we want a specific domain name linked to just a IP address, again, that's an A record. So you have to kind of understand what the record types are so we know how to query those types of responses. And I said query for a specific reason. Essentially, when we need to ask a question, I need to get to google.com, what is it? The question will be sent to the DNS server. The response should be the answering of here's the IP address. There should also be an authority, basically a resource record pointing towards an authority. This is what a typical DNS hierarchy looks like. This is what the internet DNS looks like. We have the root level at the very top. Those are all the dots. So like .com actually ends with a dot. .net ends with a dot. All of those belong to the root level. The root level actually then breaks down other top level domains. .gov, .com, .biz, .info, .org. All of those are known as top level domains. Each one then is broken down into second level domains. So if we want to go to google.com, we would actually we'd read it backwards. Dot will take us to the root level. .com will take us to the .com, the top level. Underneath .com, we will go to the Cisco level or the Google level, whatever we're trying to look up. And then from there, we will go to our subdomains or our third level domains. If we're looking at www.google.com, www is the third level. Google is the second level. .com is the top level. You actually read the websites backwards. That's how DNS looks them up. We also have a computer-based lookup if you want to query DNS to see it from a command line. That's called NSLOOKUP. That's used for Windows-based computers. And we can go to the command line, type in NSLOOKUP, and we can query different domain names and see the correlating responses. And that will be what addresses we're going to be receiving for them. One of the next major features of our infrastructure IP services is how do we get IP addresses to begin with? Two ways: manual configuration or dynamically. Dynamically actually uses what the service called Dynamic Host Configuration Protocol, DHCP. And what DHCP does is it actually leases addresses out of a pool of addresses that an administrator configures. The administrator can configure a pool of 1,000 addresses, 5 addresses, 10 addresses, whatever. The DHCP server can only actually lease addresses out of that configured pool. DHCP for IPv6 is slightly similar, but there are some weird oddities with that. So we're not going to dive too much into IPv6 or DHCP. So how does DHCP actually function? A computer comes online, what happens? Well, there is a very specific operation. The client will send out a DHCP discovery as a broadcast. The DHCP server should respond with a unicast message, and that's called a DHCP offer. The DHCP client will respond with a DHCP request, also as a broadcast. The DHCP server will respond with a unicast address or the unicast packet, and it's known as a DHCP acknowledgement. The acknowledgement is what actually acknowledges the address that will be utilized. The discovery message basically says, I'm here, I need an address. The offer, which will basically offer a lease to the client, and the client will receive more than one offer due to multiple DHCP servers, so it must choose which one it's going to select, assuming there are multiple DHCP servers on the network. Whichever one it actually wants to go with, it will send that as a request. And that message will identify the explicit server and the lease offer that the client is accepting. That is why the server then has to send an acknowledgement verifying that that is what I want. We do actually have a lab looking all of this over. Last actual major service we have to look at is file sharing. One of the big ones is FTP. Basically, what ends up happening is with FTP, it uses ports 20 and 21. It is known as File Transfer Protocol. It will pull data from a server. Step 1, we look through port 21 to connect. Step 2, we establish using port 20, and we can push or pull data based off of that connection. Another file sharing service is SMB, Server Message Block. And this is typically a client-server request response type method. Basically, we request a file or a resource, the server will respond with an SMB response, and then we provide that functionality. SMB actually is more than just files. It could be other resources. So the three main functions of SMB: start, authenticate, and terminate sessions. That's one. Control file and object resource access, and allow applications to send or receive messages to or from other devices. Those are the three main functions of SMB. FTP quite doesn't reach this level of sophistication. So with FTP, clients establish a long-term connection to the server. After the connection is established, the user of the client can access other resources, not just files. And that is this chapter in a nutshell. If you have any questions or concerns, please reach out.